Alrighty, we're going to find the solution by substitution and then verify it. So the first step is by substitution is we're going to take one equation, plug it into the other. Now to know which one to plug into the other, you want to look for the equation that has x equals or y equals. And do you see right here? Do you see how this is y equals? So this is the equation we're going to plug into this equation. So what I want to do is I want to stick this part of the equation in for y, because y is the same as 3x plus 1. So I'm going to take this and over here replace y with 3x plus 1. Again, to do a problem like this, you have to look carefully at the two equations and see which one is either x equals or y equals to start with. So I'm going to replace this right here is going to come over here and go and replace that. So I'm going to have 3x minus 2 times blank equals 4. 3x minus 2 times blank equals 4. And what is the blank? It is now going to be 3x plus 1. So I'm going to put 3x plus 1 right there where the y was. And now we are going to solve this for x. So we are now going to solve this for x. To solve this for x, I don't need to change anything on this side, but I need to simplify all of this. So the first step is distribute that negative 2. So when I distribute the negative 2, I'm going to leave the 3x. Negative 2 times 3x is negative 6x. Negative 2 times 1 is negative 2. And bring down the 4. Again, this times this is negative 6x. And negative 2 times 1 is negative 2. Leave this. I now got to clean up the left side. So I'm cleaning up the left side, so now let's combine the x's. 3x and negative 6x is negative 3x. Keep the negative 2 and the 4 where they are. So I'm now cleaning up the left side. It's all clean, and I can now solve. So far we haven't solved anything. We just cleaned up the sides. So to solve, I need to get x by itself. So how do you get rid of this minus 2? Well, you add 2 to both sides. So I now have negative 3x equals 6. And how do you get rid of the negative 3 on the x? You divide by negative 3. So I now have x equals negative 2. So that is not the answer. That is part of the answer. We are partially there. But we have now found x. Because our answer, by the way, what we're looking for, just so you know, is a coordinate. We're looking for a coordinate, and that coordinate is xy. And that coordinate is where the two graphs cross. That's what we're looking for. So what we now know is the x value of that coordinate where they cross is negative 2. So I know half my answer. Half my answer is negative 2 something where they cross. But now how do I find the y value for where they cross? I know the x. I now need to find the y. So we are now going to take x and plug it into one of these two equations. And hopefully you can tell this equation will solve easier when I plug in for x. This one will take a little bit more work. So I'm going to prefer plugging it right here. So I'm going to take this negative 2 and stick it right there. So I'm going to take negative 2 here, bring it up here, and plug it right there for x. So I have y equals 3 times x plus 1, and we are putting negative 2 in for x. Right there. Again, we could have put negative 2 right there and solve for y, but it's more work. So can we simply solve this for y? I hope you can see it. Very simple. 3 times negative 2 is negative 6 plus 1. And then that would be y equals negative 5. So y is negative 5. So xy, that is the coordinate where these two graphs intersect. So is this the solution? Our second part is to verify. This is the solution. Let's check it. We're going to verify it. So we're going to take these x and y's and plug it into both. Because for it to be true, this should be true for both. So we're going to verify I'm going to plug it into the first one. So that's 3x minus 2 times y equals 4. And again, 3x, x is negative 2, and y is negative 5. So I took this equation right here, and I plugged x right here, y right here, and is that true? Well, that's negative 6 plus 10. Does that equal 4?
Yeah, no.
Does negative 6 plus 10 equal 4?
Yeah.
Why, yes, it does. So we're doing yes so far, so good. We're half right, so it looks good so far. Let's check it again with the other one. So the other equation is this one right here. So that one's going to be y, which is negative 5, equals 3 times x, which is negative 2, plus 1. So just again, y replaced with negative 5, x replaced with negative 2. So negative 5, that would be negative 6 plus 1. Does that work?
Yeah.
Is negative 5 equal to negative 5? Why, yes, it is. So I just showed my work. This is my work. I want to see the work, or at least I want this. I want to see 4 equals 4, yes. Negative 5 equals negative 5, yes. So is it a solution? Yes. Negative 2, negative 5 is a solution. We are correct. I checked it. We are good. What that means is this is where it crosses. I can guarantee it because I checked it. I could also check it by graphing it, but I'm not going to do that. We just did substitution to find a solution, and we verified that it is correct.